Welcome to Solid State Physics, a course for undergraduate students of science and engineering. So, this course is suitable for the degree, BSc degree in physics, chemistry, electronics, material science, also for BE and BTech for metallurgy, material, electronics and cryogenic engineering. So, I am Dr. Amal Kumar Das from Department of Physics, IIT Kharagpur, and we have two tutors for this course, Dr. Tapun Maiti and Mr. Prashanto Mishra from Department of Physics, IIT Kharagpur. Course plan details are the following. So, this is 12-week course and we will try to cover the following contents. So, in first week we will discuss about atom and from atom to how solid state structure are formed. So, that we will discuss, and then crystal symmetry, unit cell, crystal planes, real space, reciprocal space of crystals, and then we will discuss how crystal structures are determined experimentally using the X-ray diffraction. Then after that we will discuss different properties of solids, such as this thermal properties of solids, electrical properties of solids, magnetic properties of solids and dielectric properties of solids. So, in electrical properties of solids, there we will cover the free electron theory of solids, band structure of solid, superconducting property of the solids, also semiconducting property of solids. In magnetic property, we will cover this diamagnetism and paramagnetism, ferromagnetism and antiferromagnetism, and then we will discuss dielectric and ferroelectric properties of solids. So, basically 5 lectures per week and 30 minutes duration for each lecture. Assignment of 10 to 20 problems in each week will be given. So, one can follow the reference books, the Elementary Solid State Physics by Charles Kittel, and also another book, main book of Charles Kittel, the Solid State Physics, Solid State Physics by A.J. Decker. And for crystal diffraction, so one can follow the books Elementary of X-ray Diffraction by B.D. Coolity. Mainly first 2-3 chapters will be useful for this course of this book, Elements of X-ray Diffraction. So, let us come to our subject, that we will start from atoms and see how solid structure is formed. So, atom have electronic structures. So, atom have basically two parts, one is nucleus and other one is orbits where electrons are revolving. So, you know that nucleus is having proton and neutron. Proton have positive charge and equal number of electrons are surrounded the nucleus. So, number of electrons and number of protons are same in atom. So, the atom is a neutral. So, these are well known to you. Now, here how these electrons are arranged on orbits. So, that following some principle, electrons are distributed among the orbits. So, basically for that we use the quantum number. So, what are those quantum numbers? You are quite familiar. One is principal quantum number, So, that is n. So, n can take value 1, 2, 3, etc. So, these basically represent the shell or orbits. So, this n equal to 1, this is basically k shell or k orbit, right, and then 2 k, that is L, and this 3 m, n, etc., right. Now, for each principal quantum number, for each n, now it has subshell or orbitals. So, that is represented by another quantum number, it is called basically azimuthal quantum number. So, that is represented by L, or angular quantum number also we tell. So, that is L. So, L can take value 0, 1, 2 up to n minus 1. So, for a particular n value, so we have n number of azimuthal quantum number. So, for each principal quantum number, we have n number of azimuthal quantum number. So, this L equal to 0, it represents an orbital, that is called s orbital or s subshell. So, 1, it is basically P, 2 basically D, then F, etc. That way we represent these orbitals. Now, for each orbital, again there are we can split using the another quantum number, that is called magnetic quantum number. So, this is basically angular magnetic quantum number and spin magnetic quantum number. So, angular magnetic quantum number and spin magnetic quantum number. So, this one will represent by ML and this one will represent by MS. Okay. So, basically ML, it will take value from minus L to 0 to plus L, and this MS that I will come later on, introducing another quantum number, that is spin quantum number, that is spin quantum number. So, that is represented by S. So, S can take only one value, that is half, and corresponding this spin magnetic quantum MS. So, it can take value plus half and minus half. So, these are the quantum number, and this will tell us that in each cell or in each orbit how many electron we can put, and in which way basically electron will be distributed among the energy levels. So, these are basically orbits, it represents the energy levels. Then again this orbits are split into orbitals, subcells. So, their energy will be different. When it will be different, it depends on the situation. So, each cell basically, or each orbit can accommodate 2 n square number of electrons. So, total number of in a orbit or cell, it will be 2 n square. So, when n equal to 1, so that means k shell or k orbit, it can have, that is n equal to 1. So, it can have 2 number of electrons, L shell, n equal to 2, it will have 8 number of electrons, then M shell, it will have 18 number of electrons. Okay. So, from quantum number itself we can distribute electrons in different orbits, and then in suborbit or subcells how the electrons are distributed, that also we can find out, like say when L equal to 0, so basically that is s orbitals. So, it can have basically 2L plus 1 number of electrons, 2L plus 1 number of electrons. That means it will, for L equal to 0, it will be 1, but that is not correct, because each electron have again spin, each electron have spin, and that 2L plus 1 it has come basically from that magnetic quantum number, that is from angular magnetic quantum number, and this for spin magnetic quantum number, for each spin, each electron can have two orientation, either spin up or spin down. So, for that, for each electron it will have two states. So, we have to multiply with 2. So, then it will be, for L equal to 0, it will be 2. So, s orbital can have 2 electrons. Similarly, you can see for L equal to 1, it is p orbitals. So, it can have L equal to 1. So, it can have, p can have 6 electrons, p can have 6 electron, d can have 10 electron, d is for is L equal to 2. So, 4, 5, 10 electron for d, L equal to 2, d orbital. So, it can have 10 electrons. Similarly, for f orbitals it can have 14 electrons, right. So, from this quantum number we can easily distribute the electrons in different orbits, orbitals, and these orbitals basically we represent that's the energy levels. So, generally energy levels we draw using the straight line. So, this way we represent the energy levels, other way also one can represent the energy levels. So, in atom how electrons are distributed, in which orbit they are sitting or they are revolving, how many number of electrons are in outermost shell or orbitals or orbits. So, these are very important because this arrangement of electron decide the properties of the atom, and aggregation of these atoms is basically forms the matter. So, depending on this, on the electronic distribution, it decide the properties of the matter. So, that's why it's very important to know how electrons are distributed in the atom. And also you see this when electrons are revolving, they have the angular momentum, you know, they have the angular momentum, and when charged particles are revolving in a closed path, so one can tell that current is flowing in a closed path. So, as if current is flowing in orbit. Now, when current is flowing in a closed path, so it is equivalent to a magnetic moment. So, it shows the magnetic property. So, due to the electron revolving in a orbit in a closed path, so it will have the magnetic property also. So, that we tell the magnetic moment. So, as you know, the magnetic moment for a current in a closed path, that one can write, say, magnetic moment mu, it is basically I A. I is the current flowing in a closed path, and A is the area of the closed path, not closed path, area covered by this closed path. So, if you know the radius of the closed path, circular path. So, this area will be pi r squared, and electronic charge of electron is E. Now, it is revolving. If you know the frequency of this rotation, then E, that frequency is nu, then that will be basically current. So, nu is nothing but this in per second how many times it is revolving. So, if you just look at a point, then how many times these electrons are passing through the point in 1 second. So, that is basically current, charge passing through a point per unit time per second. So, that is current. So, basically you can find out the magnetic moment of these electrons in a particular orbit. So, magnetic moment of electron in different orbits will be different because it depends on the radius of the orbit. So, due to the orbital motion of the electron, you will get the magnetic moment. Also, you will get the magnetic moment for spin angular momentum also. Wherever the angular momentum is there you will get magnetic moment. So, for spin angular momentum also you will get magnetic moment. So, for orbital motion as well as spinning motion, electron will have the magnetic moment. So, total magnetic moment will be the sum of these two angular momentum or two magnetic moment. So, electron have angular magnetic moment or angular motion as well as it has spinning motion. So, that we represent by L and S. Okay. So, both are angular momentum. So, whether these two angular momentum are independent, they do not bother each other, or they have they talk to each other, or they are coupled. Actually, they are coupled. So, that is called LS coupling. And that LS coupling, because of LS coupling, one can get resultant angular momentum, total angular momentum. So, that is represented by J, So, for a electron, the J can take value L plus minus S, and S is half for a single electron in an atom, S is half. So, J will for a particular electron, whether it is at S orbit or it is p orbit or d orbit, depending on that it will have total angular momentum J. So, when L equal to 0, J is half, it cannot be minus half. So, J is half. When L equal to 1, that means electron is in p orbitals. So, this J value will be half and 3 by 2. So, one can find out the angular momentum, one can find out the total angular momentum for each electron, Now, in a atom there are not one electron, there must be more than one electrons. So, only in case of hydrogen atom it has one electron, So, where it will stay? In hydrogen atom, one electron, where it can stay? Principal quantum number 1, and this S is the orbitals. So, one electron can stay here. Okay. For helium atom, 2 electron. So, S orbit can accommodate 2 electron. So, we can write 1 S2. So, similar way one can place electrons and one can find out the total angular momentum for each electron, and now when more than one electrons in atom, now each electron have quantum number, not quantum number, angular momentum. So, total angular momentum for that atom, how one can find out? So, 2 ways one can find out. First, one can find out the resultant angular momentum, capital L. So, that is basically L1 plus L2 plus L3, etc. That way one can find out. So, for this basically we use the vector model of atom to find out the total angular momentum, and then similarly total spin angular momentum one can find out S. So, that is S1 plus S2 plus S3. So, using vector model. So, capital L, it will not be one value, it will have many values. Similarly, S will have many values. Okay. So, after finding out total L and total S, so then LS coupling, that will give total J. So, again using vector model one can find out L plus S, again J will have many value using vector model. So, this way one can find out. Other way one can find out J1, J2, J3 for each electron, and then one can find out the total J for the atoms. So, that will again vectorial addition. So, it will have many values, J will have many values. So, these are very important to find out the magnetic moment of that atoms, and one can. So, whatever here we told that electron will sit in that orbit, which orbit. So, that basically we are telling that about the ground state of the atom. So, ground state of the atom, electron can go to the higher level, energy level also, higher orbits also, but that will be excited state. Okay. So, this is the arrangement of electrons in atom and the quantum number of the atoms. Okay. And these are very useful, this will be very useful for our this course. So, these are your known things, but I just remind you, and then before going to the real topics. Thank you very much.